I should have added that to my bio. That's been one of the pleasures of continuing our undergrad friendship into collaborative research, which has been very nice. So today we are as you know, we are very happy to have Professor Subbarao Kambampati from Arizona State. He goes by Rao. As he mentioned, he got his undergrad degree in electronics from IITM in 1983. He actually got his PhD from my department at the University of Maryland. And he's been a core AI researcher for more than 3 decades. So he really brings a depth of understanding of AI that I think we miss in a lot of the modern buzz about AI. So, and a little more about him. So he was past president of AAAI, which is the largest international body for AI. He's also a fellow of the ACM, AAAI, and AAAS. The one other noteworthy thing I would say is, as many of you know, research faculty often, don't care much about teaching. But in his case, if you look him up, I mean, in addition to his well-known research, he comes across as an extremely dedicated teacher, and students seem to love having a teacher like him. As you know, it's easy to please students by just giving them easy stuff, but he really seems to challenge and want them to learn the material. So Rao, I have known you indirectly since your fiery postings on sock.culture.indian from the early 90s. And we also met when you got your Distinguished Alumnus Award from our department. It's very nice to have you here. So the way we will organize the remaining part of this conversation is Rao will initially give a talk on topics of his choice, but he has mentioned some in his abstract. And then we'll have a fireside chat, so to speak, between him and me. And finally, in the third part, we'll open the floor to questions from all of you. Rao, please take it away.
Okay. I can share my screen if you don't mind. Okay. Can you see my screen now?
Not yet.
It's loading up. Yeah, now we do.
Okay, good. So, Andrea, actually, I would need the recording from you because I can't record from here, it turns out, because that's fine. I'll just get it from you. Thank you, folks, for the invitation, and thanks especially for Arvind. I always wondered how Arvind was actually very nice when I showed up in Maryland a couple of years back, and I didn't quite understand what the connection was. I guess the SCI postings obviously explain a lot. Anyway, so happy Halloween, happy Deepavali. I hope you're seeing the AI and Halloween. I think, in fact, the AI is enough, there are enough fear surrounding AI that I think that's a pretty nice Halloween talk to be giving anyway. So I want to just start, let's see if I can get here. I want to start by, I think you guys already know approximately where I am from. I've been from ASU for quite a while, and I do a bunch of things. And I also write some public interest columns on AI. And then my own research is actually on explainable AI systems and human AI interaction. That you can see my students and my big group there, and then my robots. Basically, we are interested in making sure that when AI systems, whether they are embodied robots or software systems, when they work with humans in the loop, they should be coming into our land rather than we going into the machine's land. It seems to me to be a rather sad thing for technology to develop to a point where we are all spending time debugging machines in their land. So this is something that we take quite seriously. I'll get to some of the research aspects later, but that's sort of my approximate work that we do in terms of, I think the lower video essentially shows a scenario where a commander is remotely situated and the robot is doing some search and rescue scenario. And they basically have different models of the world, and how does the robot show the behavior that makes sense to the human, as well as how does it provide explanations when humans are surprised. Those are the kinds of things that we start looking at. So before I go further into that sort of a thing, I should say a little about my IIT Madras story. I guess basically I was in 78 to 83 batch. I was in Alakananda. I was in Jamuna. I must have seen Doraiswamy at that time. I somehow, I guess, got sick of the yummy food in Jamuna and decided to change branches to go to Tapti. And in 1983, I mean, 80 to 83, I was in Tapti. I also was, I guess, in the C batch when I was in the first year. I don't know, you guys had this situation, but we were given a random vocabulary test, and that got me into the C batch. So I decided, forget about engineering, I should improve my vocabulary. As you can see, I have in like a high quartile of vocabulary. You will probably be checking your GRE vocabulary today. This is pretty much the only picture I have of my entire IIT existence in a world where we take every picture every 3 seconds. It's surprising that this is like one of the only pictures I have. You probably can't see me there, but that's me, and that's me. And I think Sohan would have seen that the other guy is Giri's son. Anyway, so I completed my IIT degree. And in particular, even by the end of IIT, which is like 5 years long at my time, I was mostly interested in sort of AI related areas. In particular, I wound up doing a work in isolated word speech recognition at that time. And with this guy, Yajna, this picture was taken in 2017 when I gave a talk at IIT Hyderabad. So it's actually interesting. I think some of you have pointed this out, is that the craze around AI that is present right now was never there at the time I got into AI. In fact, all the rest of you guys were going for the greener pastures, like the intellectually stimulating databases and networks. And so if I go to an AI conference, I would basically be able to count on hand a couple of people from even Indian origin, or certainly from IITs. Of course, now things have changed. Everybody is in AI or wishes they were in AI. And so AI has become very big. There are this huge positive hype. There's also, thanks to people like Alan, huge amount of angst about what bad things AI might do to us. This has been nice to me in various ways. I got into TV, got into White House, got even to see Sushma Swaraj before she passed away. This was in 2018. And I served as the president of AAAI, sort of making AI great again, right when the time was needed. So enough of that. So the agenda that I want to try doing today is like 3 parts really. One is I want to give you a perspective on the progress in AI in terms of tacit versus explicit knowledge tasks. And again, I think as Arvind said, I don't know, some of you may have kept track of the progress of AI, but everybody sort of knows what AI is doing right now, what AI systems are doing right now. But it would be useful to have a little more perspective on this particular tacit versus explicit knowledge. I'll mention that. Then I'll talk about understanding the risks of automating everything via tacit knowledge task methods, which is what we are doing right now. And then finally, I'll spend some time on the importance of explainability and advisability of AI systems, which is basically the main place where our group does our research. And then hopefully that will leave time for questions. So this is a very high level thing, but I think that for people who haven't thought about this, this is a very useful thing to think about. Intelligence is something that we're all proud of. We believe that we have it. And when you see our little kids doing intelligent things, you notice that they start doing perception and manipulation first. They can recognize their parents. They can put any tiny thing into their mouth. Then they show emotional intelligence. Then they show social and communicative intelligence, language, and in fact, even a theory of mind, knowing that what they believe in and what their parents believe in are different, which is when they can start telling lies, which is actually a high form of intelligence. And then finally, only finally did they do cognitive and reasoning intelligence, the kinds of things that we pay big bucks so that they can take SAT and GRE preparation and then pay tuitions for, right? Now, the interesting thing is AI went in exactly the opposite direction. In 80s, already we had expert systems. In 90s, we had reasoning systems that dethroned Kasparov. And only much more recently have we started doing good progress on perceptual tasks such as speech recognition, image recognition, and so on. So I think that the one thing that I want you to keep in mind is basically this idea that the progress in AI went in a direction that is almost the opposite of the progress in which humans get their intelligent behavior. It's a funny little factoid, but it's useful to understand this because it explains a whole lot around both the misconceptions around AI as well as the hype around AI. So why did AI develop in this reverse way? It turns out that it is easier to program computers on aspects of intelligence for which we have conscious theories. Remember, we had these things like, when I teach, I understand. When I program, I really understand. Machine learning people don't understand the task at all when they program a machine learning system. It's a very different notion of understanding. What we basically were doing was essentially explicit knowledge tasks for which we know some idea, some theory of how to do schedules, for example, and we would have developed linear programming, integer programming techniques, and so on. And so we did that fast. And then for the tacit knowledge tasks, the kinds of things like how do we see the world? How do we hold an irregularly shaped object? These are things that kids did. We did not have theories. In fact, I was in computer vision lab at Maryland, and much of the time, vision people would come up with theories about how humans do vision, and they were all bogus because we don't actually know how we do vision. We don't know how we speak. We don't know how we hold irregularly shaped objects. And for these, you more or less had to wait for the same way kids learned that stuff, which is by trial and error, by machine learning, okay? So it's very useful to understand that it's these tacit knowledge tasks that required basically, you could not tell computers how to do them. They just had to pick them up from seeing huge numbers of examples. And what happened is that the web has become it's sort of a collective subconscious. You know, if you guys know Carl Jung, it's become the collective subconscious. Everything that we do winds up getting onto the web in terms of videos, text, blah, blah, blah. And that wound up giving enough data that we could actually try and learn some of these tacit knowledge tasks. Okay, now, of course, having done that, we will get back to the point that now that we have a hammer, it looks as if everything should be done with the tacit knowledge way. And it turns out that actually has major problems. And I'll, hopefully point that out to you in a minute. There are, given the times, there are bunches of, the things that are working, of course, for the tacit knowledge tasks, the deep learning. People are aware of deep learning stuff, but most people don't understand that essentially we are at this lookma, it works sort of a wanderer stage. We have no real strong theories about why it seems to work. In fact, something as simple as most of the systems that we have these days, like the GPT-3, has like 175 billion parameters that it learns from just 8 million web pages. That means you're learning more parameters than the examples that you're seeing. And that's in statistics. For those of you, with the background in statistics, that's basically the huge problem of overfitting. And how are we avoiding overfitting? There are various theories, such as the double descent theory that we can get into if you're interested later, which seem to suggest that maybe what is happening is beyond a certain level, overfitting. If you continue doing training, then essentially the regularization steps in, and then the hypothesis become more smoother. But these are basically speculative theories at this point. We really don't know what the failure modes of these systems are. And it's very important to understand that. Many of you have probably seen this picture. There's a school bus on the left-hand side, and I add this imperceptible noise to the school bus to get this right-hand side school bus. And most ImageNet competition deep networks essentially will give a higher confidence to the classification of this right-hand side school bus as an ostrich. It's not a school bus according to them. It's in fact, they think that the school bus, the original school bus is 84% accuracy. The ostrich is 97% accuracy. So when it says school bus, you are happy because it agreed with your understanding of what a school bus is. When it failed, you have no idea. And not understanding failures of the systems should make us as engineers very worried. Okay, I understand that we were building bridges way before strength of materials was ever taught anywhere. But we also spent a lot of time figuring out exactly when will bridges stop working and start falling. And that's why we don't have bridges falling off as much. And that's something that we are not yet in there in AI. I also want to kind of give you this example that I find that many people get a lot out of this, that the visual fallacies, the optical fallacies are there for people too. In the bottom right here is a picture from Norway couple of years back, where people, this was going on Facebook in Norway, and they said, oh my God, Norway is being taken over by burqa-clad Muslim women. We need to stop this from happening. Okay. Now, obviously, those are bozos, bigoted bozos, but you can kind of see why they thought the normal city bus seats are Muslim women in burqas. You can kind of see it. You don't understand their racism, but you can understand their optical fallacy. Now, having said this, now go back to the ostrich school bus, and can you kind of see why it is an ostrich at all? Even if I keep looking at it, that is the difference in failure modes. And we are using systems whose failure modes we don't understand, and that we need to be careful about. For example, this one is a paper from a couple of years back in 2019, where they show that for all these pictures downstairs, the systems will give the same top 1 to 1,000 rank. Okay, so from top 1 rank is bullfrog, top 1,000 rank is tiger shark, for any one of these pictures. So that's the level of our misunderstandings about the failure modes, about these things. So this sort of course, the systems are working. There's no question that the systems are working extremely well. Large language models such as GPT-3 do a great job of college level bloviation for any prompt. I mean, come on, we wrote essays and we knew how to kind of BS our way through writing long essays. Now we don't even have to do that. The machine can do this for us. And they would be great tools for computer-supported cooperative work. This is what I was saying in this CACM blog article, I believe some of you read. But there is a rush to use these kinds of systems in autonomous modes with no human in the loop. And some have even dubbed them foundation models, some in your backyards. And a recent system called Delphi, for example, is trying to build on top of these kind of loose foundations to have AI systems do ethical judgments. And once again, a few ethical conundrums that are presented to Delphi does right. You feel extremely good that, oh my God, it is actually agreeing with my understanding of ethics. But it turns out it's an extremely brittle system whose brittleness has no bounds. So this was an example that I was showing in my class last week. So here I just said a bunch of things with just changing one word. So first I said, making public a descriptive ethics model based on shallow large language models. Delphi says it's wrong. Then I just say, amazingly shallow large language models. It says it's good. And then I say uncurated large language models. It says it's wrong. And I say gloriously uncurated large language models. Once again, it's good. You can see where this is going, right? Essentially, the failure modes, no human would do this sort of nonsense because this is completely syntactic understanding. And these are extremely useful with computer-supported cooperative work with a human in the loop. But without that, you should be really, really careful in using it. So because of this sort of a hype and misunderstanding, I've been spent some time last couple of years writing like the public outreach articles on AI, what just happened, and then also the deepfake stuff, and also why AI systems seem to be biased. And then finally, will AI systems ever get along with us? And these are basically reasonably general audience, but sophisticated general audience articles in the Hill that you might be interested in looking at. So that's the first part. The second part is understanding the risks of automating everything via tacit knowledge tasks. Back a couple of years back, when Jeff Hinton was in town in Phoenix to take his Turing Award, he basically made this talk by saying, differentiating between intelligent design, where you tell computers what you want done, and then learning, where you only give examples to the computers. And he makes this very interesting point somehow that, the very use of the word intelligent design is a put down. In science, nobody wants to be associated with intelligent design. But the point is that he's just reinforcing the AI zeitgeist, if only in a sort of a doctrinal form. AI technology managed to catch public imagination mostly because of the tacit knowledge tasks. But when, the human intelligence basically involves doing both tacit and explicit knowledge tasks. I don't just keep showing you examples. I tell you my requests, and I provide, if you join a company, the company might have some sort of a, employee, operating manual, saying, no, I don't want to read that manual. Just tell me the examples of, people working in this environment, and I'll figure out myself how to work in this environment. Seems like an extremely inefficient way to do things. So this is sort of connected to this new romance that we have. Actually, we always had, humans had a romance with tacit knowledge. I point this out in the CSEM article that, in fact, if your loved one ever asks, why do you love me? Don't ever give 1, 2, 3, 4, 5, 6 falsifiable reasons, then you won't have any relation, okay? We always think this, sort of, je ne sais quoi, that means I just love you for things that I can't define. We fall for this sort of tacit, unexplainable things, right? Polanyi, who's a sort of a polymath and philosopher, used to bemoan the fact that science mostly focused on explicit knowledge tasks, and that a lot of human intelligence is really tacit knowledge. Clearly, doing speech, doing vision, etc., in the beginning, at least, are completely tacit knowledge tasks. And so he was worried that there's not enough attention being paid to tacit knowledge. It turns out that actually we now have a Polanyi's revenge, because to some extent in AI, everything is being converted into a tacit knowledge. You guys may have heard of this idea of from data to knowledge. Actually, what is happening in many places, including places like OpenAI, is from knowledge of humans to data, so that you will then somehow get some version of the original knowledge by these examples. So one piece of knowledge will be converted into 10,000 pieces of examples, which then hopefully will be understood by the machine by somehow looking for patterns in it. That's a highly inefficient way to do things. And we need to have an idea of figuring out how to exchange information in more explicit knowledge terms, especially when such a thing is available. When only examples are available, such as like, what makes Rao look like Rao, the only things that you have are examples. But why did Rao get delayed in coming to the talk? There are actual symbolic explanations that you can provide, and you should be able to take that. And this is important for humans and machines to coexist, both for humans to provide advice to the machines and for the machines to provide explanations to the humans, so that we can live our lives, and it's the machines that sort of make enough changes in their way of working such that they make sense to us. It turns out that the Polanyi's revenge actually has a huge amount of ramifications. It turns out all these things like interpretability, that we don't know what the machines are doing. Well, you don't know because you're letting the machines develop their own representations, and you're not forcing them to communicate with you in terms that make sense to you. So you need to provide, require the AI systems to communicate with us in terms that make sense to us. If you don't have that, interpretability will be a problem. Susceptibility to adversarial attacks, you celebrate success modes where you and the machine agree, but the number of times they fail can be quite unlimited. And then finally, susceptibility to data set bias. It's not that people don't have racist, sexist thoughts. Your system one probably is making, as we speak, random thoughts, but your system two is able to actually censor them. You want your systems to, you should be able to advise AI systems that, in addition to all these examples, here are the civilizational rules. And you should be able to convert that into, the machine should be able to digest that. Currently, the only way we can do this, in fact, OpenAI guys try to reduce the bias in the GPT-3 outcomes. And the only thing they could do is first write down their own rules in essentially symbolic form, then convert into a huge number of examples, and then feed them to GPT-3. That's a silly thing as far as I'm concerned. You should be able to communicate with machines, and they should do this conversion. And those are things that we should be looking into. Otherwise, you have all these other problems. So, I think for this part, I want you to remember that, basically I have this serenity prayer, the usual serenity prayer, which is on the right-hand side bottom that many of you know. Robot should have a serenity prayer too, that human grant me the serenity to accept the things that I cannot learn, data to learn the things I can, and the wisdom to know the difference. And we should get AI systems to that point where they're essentially not just sort of only focusing on raw data without any background knowledge. Okay, that's the second part. And I want to spend a few minutes on the third part, which is the importance of explainability and advisability of AI systems. And sort of, I motivated that to you a little bit. This was probably my most famous tweet ever. I did this, I was teaching to my class about machine learning and explainability. And so I went and bought this t-shirt, which essentially says algorithm is when programmers don't want to explain what they did. Heuristic is when programmers can't explain what they did. And machine learning is when programmers don't know what they did. Okay, that's reality. Essentially, when you're learning from examples, it's like almost astrology. When astrology works, wow, astrology works. You don't count the times astrology fails. So astrology is alive and well in India. And I'm sure AI is way more effective than astrology, but we are not counting the failure modes enough. And we need to be careful about that. And to control that, we need the AI systems to be explainable as well as advisable. That means they should provide explanations to us, and we should be able to provide advice to them. So this is sort of very high level view of a couple of slides of my work. What does it take for an AI agent to show explainable behavior in the presence of human agents? It's the same thing that it takes you and me to show explainable behavior in the presence of each other, which is mental modeling. I don't know how many of you know Sally Ann test. If not, let me just walk through it. So Sally is in red and Ann is in blue. Sally comes in, puts her ball in the yellow box and walks away. Then Ann comes in, moves the ball from the yellow box to the gray box. And then now Sally comes in. You are seeing all this stuff. And I'm asking you, where do you think Sally will look for the ball? And some of you probably know that, I hope that most of you know, you're all IIT, JEE folks, so you all know the answer. But it's interesting to know that kids below 3 have trouble figuring out, because they assume that since they have seen that Anne has put the ball in the gray box, and since they know it, maybe the entire world knows it. So they don't know the difference between what they believe and what the rest of the world believes. And then about 4, they realize this, and that's when they start telling, glorious lies. So I joke that when my kid, who's now, having a job in Florida, when he started lying, as an AI guy, I was extremely happy, because I knew he had a functioning brain and it can do mental modeling. Lying is high form of intelligence to some extent. I tend to tell my students that integrity is knowing that you can cheat and choosing not to, rather than just not even knowing that you can cheat. Okay. And similarly, lying is sort of, to be able to lie, you need to know that other people's belief systems are different from yours. And you need to know that to cooperate with them too. You need to tell your wife, or your husband, you're getting delayed because they don't know that you're going to get delayed. And you need to provide that information beforehand. And this management of mental models is what winds up being the foundation of our research. In particular, if a simple robot is just trying to achieve some goals from some start state to go to some goal state, it just needs one model, its own model of the environment and the task. But when there's a human in the loop, it needs to start thinking about the human's model of the task and the human's beliefs, human's desires. And that's basically what we normally talk of as essentially intention recognition of the humans in the loop. This is all stuff, work that being done in my lab. So basically the machine's trying to get an idea of M of H, which is the human's model. And sometimes machines providing a heads up about what they're about to do, either by speech or by, in this particular case, HoloLens and augmented reality. But then there's a third part, which is when the human is in the loop, humans always anthropomorphize the tools that they're working with. They tend to think of them as partners. And so they will have an approximation of the model of the robot, which is this MRH that the humans have. And the humans are trying to interpret the robot's behavior in terms of whether or not it is consistent with MRH. And when it is consistent, it is explicable. When it is not, it is inexplicable. And when the robot tries to be always consistent with the human's model of its behavior, it sometimes has to do very costly plans, because as you all know, living your life based on other people's expectations of you will avoid you ever having to talk. But on the other hand, it also makes your life hard because you're doing things that are expected of you rather than the things that are easy for you. So when sometimes a robot can decide to do what is cheaper for it and provide an explanation of its behavior in terms of the human's expectations, saying these are the ways in which your expectations of my model are different from the truth of my model. And that's basically what we wind up doing in terms of explicability and explanation. So I'll just show you two little videos and we'll stop. So in this particular case, again, this robot is going, and the human, basically, as I said, the human commander assumed that this particular path would be available because, but then it turned out when the robot went into the environment, it found that this path is closed. So it has two options. One is not to take that path, but other is actually take that path by cleaning up that path, removing the rubble. When it did this removal of the rubble thing, it didn't have to speak at all because the human expected the robot to do this and the humans are not surprised. That's exactly what I expected the robot to do. The other possibility is when the robot essentially, it decides not to remove that obstacle, instead takes the next better path. This is something that the human didn't expect, and so it needs to provide an explanation. It's just saying, here is the minimal difference between your model of my map as well as your, my actual map. And that winds up being explanation. And this three-model account has all sorts of interesting properties from the way humans explain things to each other. Surprise happens when the robot's behavior is not consistent with what human expects. And then then that is when essentially the explanations are provided to bring the models together. This is model reconciliation. One last thing is that notice that in the work that I showed you, I've started talking about models. Now, if one of the models is in a completely different vocabulary from the human's model, so as is the case, for example, with the deep learning systems, then what happens is the model changes are harder to specify. And then it turns out that currently in much of machine learning literature, we focus on these pointing explanations. These are the pieces of the image or the space-time tube that made me do what I did. And those turned out to be a particularly inefficient form of exchanging explanations. We more or less invented language so that we can provide symbolic explanations to each other. And then you provide me an explanation, I probably convert it into a video in my head myself, rather than you having to provide a video. And so we essentially are working on this dealing with the handling of different vocabularies by having the machine itself generate a local model that is symbolic and that's in terms that humans can understand, and then providing explanation in terms of those models. Notice that this way the machine can still do its deep learning, its own representations, which may not make any sense to you, but it's able to provide post hoc explanations. It's the same thing that we all do. I don't quite know what is going on in your minds. It's the talking that you do with me is what I can understand. And that's basically what you'll wind up having to do. And it turns out the same kind of an idea can be used for advising systems, machine learning systems. So humans will provide symbolic advice and the machine can then interpret it by, for example, converting it into more examples itself. Rather than the humans converting their symbolic advice into many, many examples, the machine does it. And there is a paper on this in NeurIPS this year from my students. So in particular, so by the way, that whole work is actually is coming out, that whole direction is coming out as a blue sky paper at IIIT 2022 on symbols as a sort of a lingua franca between machines and humans. And then sort of a summary and additional pointers here. I sort of gave you 3 different pieces. If any of these pieces is more interesting to you and you want to drill down, there's a whole bunch of talks that I have on those specific parts that you can look at. But and then you can always contact me by email, etc. And I'll stop here. I know that I'm like probably 5-6 minutes more than I was asked to go, but I'll stop here and hopefully we'll have enough time to take questions. Thank you.
Thank you, Rao. Maybe we can start. So I thought we can have the quick fireside chat now, but there are many interesting questions in the chat. So why don't we start with the questions? So Rohini asks, the framing of we should invite AI into our worlds and not have to mold ourselves to the machine world is great. Can you say more about this?
So that's basically what is happening here in both these cases. So what happens in these sorts of scenarios is essentially the machine may well, this one is actually the machine is doing some reasoning in the context of some Atari game, which basically has become very popular of late when deep reinforcement learning systems were used to just go from pixels to actions without any intermediate ideas like symbols and objects. So the machine itself is potentially going from pixels to actions. But the humans might be asking, why did you do this decision? And the usual way would be to say, here are the pieces of the pixels in the space-time tube that was more important for the machine to make its decision. But those are useless explanations for the humans because that's what I would do if I'm just debugging the system. If I basically want to live in my own world, then what basically we support in this case is the machine will, around its around the decision it made, it actually converts the reasons for that decision into a vocabulary that it basically pre-specified vocabulary that humans understand. Now, you might ask, where are the pre-specified vocabulary coming from? Well, it turns out that, for example, if you think of things like scene graphs, I'm assuming from your question that you probably have background in AI. If you think of things like scene graphs, where basically people look at an image and generate sort of a knowledge graph of things in objects and the connections between them. Objects only make sense to us. They don't make sense to machines at all. They don't ever have to make sense to machines. And the reason those scene graphs make sense is basically if you can convert the reasons, the machine can convert the reasons for its decision in some approximate way into the objects in the scene graph, that would be the machine making its reasoning transparent to us. Now, when you do that, there is always this problem that the explanation that the machine gave is not the true explanation. Okay, you are always approximating, but explanations are always reconstructive. There is no such thing as true explanation. You basically provide an explanation that allows the other person to understand part of the reasons for your decisions. And then that might start a continuing dialogue where they might ask more questions, which will then involve the kind of this translation of your decision into the vocabulary that humans have. The distinction here is there are right now like two branches in AI. In fact, I'm giving another talk tomorrow morning. It's been a crazy weekend for me. At 8 o'clock tomorrow morning, I'm giving a talk in a workshop on knowledge injection into neural networks. This is sort of a neuro-symbolic AI community who kind of believe that machines must have symbolic reasoning internally. My point is that I don't necessarily know whether machines must have symbolic reasoning internally. They must know how to talk to us in symbolic ways. Think about emotions. Must machines have emotions? I don't know whether emotions necessarily are required for the performance of the internal performance of the machine. If the rover is on Mars, must it once in a while feel sad? Not necessarily, probably not. But if the rover is working with you and you stubbed your toe and the rover makes a funny little smile, you feel like hitting the rover, okay? The point is, the machines need emotions to work with us, even if they don't necessarily need to have emotions. Similarly, the machines need symbolic explanations to provide to us, even if their internal reasoning may or may not be in symbolic ways. Now, if it is already in symbolic ways, it turns out, in fact, some of our work, some of the earlier parts of these couple of slides that I showed you on model reconciliation was assuming that the machine also has a symbolic model. By the way, there's a humongous number of tasks, such as in scheduling, such as in planning, where in fact people have models for the machines, and those are symbolic of some level. The humans have some symbolic models, and you still need explanations there. That can be done. That's not a problem. It's just that it also can be done when the machine isn't even thinking in any symbolic form.
Yeah. May I ask a quick follow-up?
Sure,
and maybe a longer answer, but I'm sort of wondering, this works when it's one human to one machine. So if I'm a human, like, in that I'm the authority figure, like I train this machine to expect what I like, right? Now, if I give this machine to work with somebody else, like, for it to know what the expectations are, you need to have a lot more context on who this other human is. So as long as humans are all different, right, there isn't one human world versus one machine world.
Completely.
And I think a lot of the problems that we see is when, when I as a human, I create a machine that is a very obedient, good machine, in my estimation. But like, because other humans are different, when that machine interacts with other humans, it may be doing things that are extremely wrong and bad in their worlds. How do you like, how do you box it such that, the human stays important, but not, it's impossible to know all the humans this machine might interact.
Okay, so there are like 2 points. First of all, I basically completely agree with you, but then I will try to explain to you how this can be still done. First of all humans are more alike than machines are, than they are with respect to machines. In the sense, we still make sense of symbolic explanations. We tend to mostly, exchange symbolic explanations and so on. And so, and similarly, for example, scene graph, which is when I look at a scene, more or less all humans seem to look at the same kinds of objects in approximate relations to them. So we do have a lot more in common than we might differ. Having said that, my entire work essentially completely, and in fact, I think there was a slide that I went back on, I might go back to it if I can, which basically, actually, let me see, yeah, this one, that essentially the human models are very much dependent on the individual human. So presumably it will be some default generic model plus customized to the specific human that you are working with. And you do need to essentially assume that you're making sense, your explanations make sense to the human in the loop. We have a lot of work in the papers that we've written, which provide, for example, allow for machine to provide customized explanations to both, for example, a commander as well as an assistant in the loop. And as the usual thing, doctors provide explanations for their decisions to patients at a very different level of abstraction than they provide the same explanation to their colleagues. Again, it's the MRH. The H is not one human. MRH1, MRH2 can be possible. And so you can essentially wind up having classes of humans. this is very much par for the course. We have papers on, in fact, there's an IRAS paper this year, this fall, by one of my students on providing customized explanations for multiple humans in the loop. And then again, the other thing that I want to kind of reinforce what you said, some people, including good friends of mine, such as Stuart Russell, essentially want to somehow save the world from the AI by providing quote unquote value alignment, where essentially you will get to stop the existential risk. You will provide value alignment systems where machines will understand human values. The question is, there is no one single thing as human values. Stuart Russell might essentially make sure that his robot will follow his rules, but then North Korea or whoever is your favorite bad guys will have a different model who will then essentially train their machines that way. And so in a way, actually, this is always par for the course. There is no such thing as a single human, but it's at the same time, it's also not the case that all humans are completely different from each other. This is something that's worth understanding. I keep thinking of the fact that the human intelligence as a whole is at a very different level than pretty much anything else in the animate world. And we are already at that level. And then we start making distinctions between, oh, you got only 344 rank in JEE, while my God, I got 343 rank in JEE. So I'm completely better than you. It's good that we make that, but it's also important to realize that it's in a very different plane altogether. There's a lot that is common. And I want to give one more analogy for you guys just to think about this. One time I went down to Tucson, which is a little town next to mine, and they had in their Sonoran Desert Museum, they had the globe to scale, a huge globe to scale, with including all the ups and downs of the globe. So you would think that if you just walk down, you think, oh my God, if I put my hand at the Himalayan region, it should be poking me because the Everest must be poking me, right? It turns out that you will be surprised when you first do it, because the height of Everest compared to the radius of the Earth is so small that barely any difference. And yet you stand next to Everest and say, oh my God, Everest is slightly taller than Makalu, which is not as tall. And that's the kind of customization we are talking about. It's important that that customization is done, but it's also important to understand that all humans do share a lot more in terms of some of the biases they have, some of the object bias and the whole object biases and the kinds of objects they see in the world, etc. And so it does, you can exploit both of those.
Thank you. Yeah, I'll go to a few other questions. So Karthik asks, what is in understanding images and language, etc., that humans trump current state-of-the-art AI approaches? Are there aspects of these fields where humans...
Pretty much anything which involves reasoning, okay? Basically, humans can do way better than machines. Reasoning, so I mean, the idea basically in language, if I give you a word problem, as long as the word problem's answer is almost like an epsilon step away from what is written, machines can do it, GPT-3 can do it. Any kind of actual reasoning which involves sort of realizing the sequencing and so on, that just is not possible for the language models. Now, of course, you can do reinforcement learning agents, which can obviously do way better. AlphaGo does way better Go than any of us can do. This is where one more important point that I forgot to mention should be brought into fore. There is deep and narrow AI systems and broad and shallow AI systems. Deep and narrow AI systems, they make a big splash. And, oh, wow, suddenly we are no longer the masters of chess. We're no longer the masters of Go. But then we'll forget about it because you don't know how to use AlphaGo or Deep Blue in anything else. And so you move on. Broad and shallow systems, such as the GPT-3, such as the very impoverished bag of words model, for those of you who background in that, essentially don't do anything with guarantees, but they do everything kind of badly. And those systems are actually what is driving the hype in AI right now. It's the GPT-3s. It is, I can recognize lots and lots of images, maybe with some errors here and there. These are the things that are driving images. It's not the hype. It's not the deep and narrow AI. And what you eventually want is broad and deep AI. And that's still to be, broad and deep AI, that's still not there yet. So in terms of image and language, mostly image and language models right now in NLP, it's strange. NLP has become just deep learning. And the linguists are very unhappy. They kind of say, oh, there should be meaning, blah, blah, blah. But essentially, the only thing that sort of seems to kind of work and everybody is crazy about is essentially doing this completion of, given the following words, what would be the next most likely word? And given that, what's the next most likely word? There is no intentionality in putting those words together. They're only being put together because they have a higher probability with those words. And one of the funny things is in that language models, CACM blog, I sort of start with my kid imitating how we used to speak on the phone, while that lots of people like that analogy. But one interesting difference is even when my kid, way before my kid could actually make syntactically correct English or Telugu or Bengali sentences. In fact, for the longest time, he won't speak anything because he decided that my wife should make up our minds as to what language is being spoken around. And so he waited until English started getting spoken. So up until then, he had no syntactic language, but he had complete intentionality. He was trying to convey something very specific. Intentionality is completely missing in LLMs. That's the thing that you're hoping that, when somebody says the essay makes sense, well, the essay makes sense because it's sort of a garden path essay, which sort of seems to have paragraphs that are not bad. It's a huge advantage to be able to write syntactically correct English. Okay, I'm not downplaying that. But at the same time, what we do is we not only provide syntactically correct English, but we are also trying to do this in support of some goal, which is what I think I am doing right now, which is what I think you guys are doing when you are asking questions. That is something that language models can't do right now. And that's basically the next big step that nobody really has very good ideas. And I'm not completely sure that language models will be the front and center of the next stage of necessarily making things intentional. Although certainly they are working well, so it's worth giving them, worth trying to exploit them more.
Okay. So I'll have to unfortunately pick and choose from the remaining questions given the, given our time constraints. Let me ask a question from GDS, which is whether you would agree with Andrew Ng's framing of the limitations of AI, that a computer can be trained to perform any task a human can do in well under a second, like 100 milliseconds. That is fast thinking according to Daniel Kahneman's definition. It's feasible, but slow thinking / reflection is not yet within reach for AI systems.
Can I add a little bit to that, Arvind? Professor, I really appreciate the lucid explanations. Really, the field comes to life. Thank you for that. I think during the talk, you alluded to System 1. So let's say as a business, I want to set problems that AI can solve. Is it fair to say that System 1 is within reach and System 2 isn't and requires a breakthrough we haven't found?
So unfortunately, I had actually a slide on that, but I would just tell you. So the interesting thing is System 1 and System 2 have connections to tacit and explicit knowledge, but they're not one and the same. Okay. Much of explicit knowledge starts at System 2, essentially, but you do compile it. Okay, things, which is what we wind up doing. We did, derivatives with fx plus h minus fx by h tends to 0, but we no longer do it. I mean, we basically compile the heck out and then you see log x, the derivative, that sort of a thing. So for the explicit knowledge tasks, when they are done in System 1, it's because they got compiled. And the advantage of compilation is if the compilation goes wrong, you can go back to the source code, which is the explicit knowledge. For the tacit knowledge task, there's nothing in the system 2. We really don't have much of a basis for vision, raw vision as well as raw language and speech at the system 2 level. And so that is where essentially if something goes wrong, there is nothing you can point to saying, this is the reason I decided this is an ostrich rather than a school bus. There's no explicit knowledge thing, okay? Now, with respect to your question, it's a strange thing that, in fact, much of AI, as I was saying in the beginning of the talk, much of AI is basically about system 2-ish tasks. Let me just show you that. Much of AI, like expert systems and the reasoning systems, etc., they were all system 2 tasks, essentially. Okay. In a weird sense, people have this collective amnesia. So, in fact, I have this thing that I know that somebody is post-AlexNet generation when they say that one of these days AI systems will hopefully do reasoning too. That's bosoness, because AI systems were extremely good at doing reasoning without knowing how to connect reasoning to perception. Okay, so you have perception, you have reasoning. Of course, there were attempts to make somehow some sort of a top-down thing work, which is the same methods that worked for system 2-ish explicit knowledge tasks, hopefully can work with perception tasks. That didn't go anywhere. Now there's the opposite attempts, that the same hammer that worked for system 1 tasks, the tacit knowledge tasks, will hopefully work for everything. And that has its own problems, which is basically what I was saying, that in fact, all these worries about biases, etc., come from the fact that many things which are actually explicit knowledge tasks, you're converting them into tacit knowledge tasks because your hammer is learning from a huge number of examples. Okay, so I don't know if that answers your question, but essentially, yes, if you're talking about can we get something like a neural network system that can do both perception and the kind of reasoning that expert systems can do, yes, that's an open question. Nobody yet knows how to do that. But on the other hand, both of these exist in different places. We know how to do the top, you know how to do the system 2, you know how to do the system 1, and you don't quite know how to put them together yet.
So Rao, I have a quick question. So as we all know, technology, including wireless networks, really helped us leapfrog. So I am talking particularly about developing countries like India. Helped us leapfrog, say, poor wired infrastructure to go directly to wireless and all its applications in banking and so on. So where do you think in the developing country context that AI is maybe being underinvested in, and where, when properly deployed, it can leapfrog, current challenges? Any thoughts about that?
I mean, I guess there's like a variety of things. Certainly, I mean, I was, as I said, I was in that thing that Sushma Swaraj ran, and then I went down to the, what is that thing called? This Anna Roy runs this particular organization in India, which supposedly does the planning for technology planning. And my thing to them was basically they were just trying in the complete exploitation cycle, which is convert everything into examples and see what neural network architecture will work, which is a very reasonable thing to do. I think actually the what's that thing, the institute in Bombay, which the institute that this guy is not Advani Institute, something I just forgot the name, that these two brothers started, which is actually
Wadhwani AI.
Wadhwani, yeah. So I remember Advani for some reason. Okay, Wadhwani AI.
So Rao, Sunil Wadhwani, the younger brother, he's an IIT alum.
I know, he called me actually before the Wadhwani Institute started. He called me and we talked for a while, and then he was talking about what are the ideas about. This was way before when Anandan got hired. Before Anandan got hired to be the head. So I haven't met Sunil in person, but we talked once.
No, he's totally, they're totally into this area, right? They actually
I know, very much so. They have spent a lot of money, etc. And they basically they're very well intentioned. I think they're going in the right directions. I mean, I know like Rahul Panikkar, for example. I'm not sure whether the same people are still there because there's been like a turnover. Anandan left, and I think Rahul Panikar also may have left. But I mean, going back to it, they are basically looking at data science applications right now, okay, which is a reasonable thing to do. But I think it's a useful thing to do. I'm not really sure. I think more of my questions are, you should assume that the data science applications of just basically directly applying something out there will lead to the usual problems that I was mentioning in terms of in terms of the interpretability, etc. Let me just bring that back. So the point basically, let me see, I just wanted to put that. Yeah, so that one. I think but exploitation at the development level is quite a reasonable thing to do. At the research level, research is the same whether it's in India or in US. I mean, we have to remember, by the way, most of us probably have forgotten that there was nobody doing neural networks in US, like nobody, which is why basically there are no senior neural networks researchers in US. There were just a couple of people who were like basically decided they were going to spend their life on it. Jeff Hinton and his folks in Toronto, and Schmidhuber and his folks in Germany. And the rest of us were basically doing other stuff, right? And so in fact, from a research perspective, the big next thing might very well come from some place other than where the exploitation of the current technology is occurring. So I think for the research, it would be the same story, whether it's India or US or Afghanistan or wherever. In terms of development, clearly you should use the technology that is available to you right now and then figure out, know for sure what the limitations are and then apply. And I think Wadhwani does a reasonably good job on that.
Okay. So we have some more questions, one from Rohini, one from Raji Bhaskaran, one from DP and others. Unfortunately, I think we are a little out of time, but I'm happy to stay if some of you and Rao.
No, this was great. No worries. I mean, it was really fascinating. So no problem not taking the questions.
Yeah, I mean, I'm happy to answer questions. If you are here, I can answer. Otherwise, that will be fine.
So thank you very much again, Rao, and thanks a lot to the IIT Madras Foundation again. Karthik, you want to mention something before we conclude? Okay, Karthik is...
Arvind, if Dr. Rao is willing to stay behind, I'd like to stay behind and ask a few questions.
That's fine. I'll be here.
Thank you so much. Fascinating talk.
Thank you.
No, I know Prakash and Raji joined, so do you want to introduce yourself?
Hey, Karthik.
Yeah. Thank you, guys.
Yeah. So Arvind, may I ask a question or?
Go ahead.
Go for it.
Okay. Yeah, absolutely fascinating. What a treat. What a treat on a Sunday. Sorry, it came a little bit late. I'm DP Prakash. I'm co-CEO of a company called Utopian. After working for 2 decades at IBM and about 6 years with the CEO of Global Foundries, reshaping innovation semiconductor field, learning AI and XR is where the highest value is going to be. At least that's what we believe. From the factory floors, that's what became obvious to us. Went off and started Utopian, helping a lot of different C-suite leaders, and just came back from our talk in Pennsylvania, 43 different companies. So it's fascinating to see what's going on at the intersection of AI and XR. I wanted to hear your perspective, sir. What are your observations? You mentioned HoloLens and what you're working. Any observations where AI and 3D systems, visualizations, anything that stands out in your mind is, you know what, this is going to be an interesting thing to watch?
I'm basically we did use, I'm not an expert in that direction as much. I mean, obviously everybody is talking now about the metaverse, the situation. Yes. I was actually an advisor to a company. I'm still an advisor to a company called AI Foundation, which was mostly doing the work on digital twins, mind twins, what we would call mind twins, which is exactly kind of connected to this metaverse situation. Yes. So in the case of mind twins, it turns out there are like a stack of technologies. Up front, there is this issue of embodiment, the way that you need to be speaking like a human with the right pauses, etc., etc. Those are all really, really, we have come a long way thanks to deep learning. Essentially, in terms of, with enough knowledge, with enough data, you can actually show very smooth movements, very smooth intonations and everything. That's pretty impressive. And we were also looking in that one, for example, at how to make basically the embodied agents essentially have goals and make sure that they're giving answers that made sense to the human. So our idea in that company was essentially that celebrities can have digital twins, and you can talk to the celebrity's twin instead of the celebrity himself or herself. There is a thing called Digital Deepak that you can look up on the web, which is like a little app, and then you can talk to Deepak Chopra, who would then sort of lead you through yoga and all that stuff. So I think from my side, given my background, I was looking more from the perspective of how to ensure that the exchange of the dialogue is a purpose and intentionality. But certainly the actual AR, VR, AR technology in particular, becoming right is very important. They basically, this whole thing about the uncanny valley business, as I think we are doing, from what I can see, we're doing reasonably well with the uncanny valley part. People, there's enough, improvements in technology that you can make things. There's an entire talk that I have on the deep fakes, etc. That's a whole entire interesting world altogether. But we can make deep fakes, but we still need to get them to, we need to manipulate the deep fakes. So most of the time, deep fakes attacks are humans essentially attacking you through deep fakes rather than AI systems just intentionally attacking you, which I guess is a thank God situation. But on the other hand, as a researcher, I would like to see whether that too is actually possible.
Thank you, Dr. Rao. I'll write you offline.
Okay, thank you.
Thanks.
Thank you all for the conversation. Sorry, we are speaking about AI, but I'm dealing with AT&T broadband issues in Nashville. So sorry about that. Fascinating conversation. Arvind, thank you so much for, moderating it. I think we'll connect everybody on this call with Rao let's take it offline. Thank you so much.
Thank you.
Thanks. Thank you.
Thank you so much, Rao.
Excellent talk. Thank you so much.
Thank you.
Happy Halloween and happy Diwali.
Thanks so much.
Happy Diwali, everyone.
Happy Diwali, guys.
Yeah.
Andrea, I would like to get the Zoom recording when you get the thing, please, because I couldn't record from my side. I would love to have the recording.
I'll make sure to send it to you. Thank you again.
Thank you.
All right.
Thank you. Have a good one, everyone.
Thank you.